In this section, we will learn about instrumentation amplifier. The circuit here is a circuit of a simple instrumentation amplifier. It is made of two main stages. First is the input stage and second is the output stage. Instrumentation amplifier has two inputs, okay, as we can see here, VA and VB, and it has one output. Typically, this VA and VB are connected to the Wheatstone bridge. Okay, in the previous section, we learned about Wheatstone bridge, and Wheatstone bridge has two outputs, VA and VB. These outputs, the VA is connected to here, and the VB is connected to this input. Okay, so whatever measurement is made in the Wheatstone bridge will be detected through this VAB, and that in that measurement we will feed it inside the instrumentation amplifier. So next we will learn about the input stage of the instrumentation amplifier. Okay, this input stage has two inputs and it has two outputs. So we will learn about this. Okay, as we can see here, this is the circuit diagram of the input stage. And if we observe carefully, this is made of two non-inverting amplifiers. Okay, this is one non-inverting amplifier and this is another non-inverting amplifier. Okay, and it also has two inputs and two outputs. The difference between the output, okay, the difference between the output is given by this expression. If we analyze the circuit, we can derive this. Okay, the V2 minus V1 is the difference between the output, and VBA is basically VB minus VA, which is the difference between the input. Okay, and second, the sum of the outputs, okay, sum of the outputs is V2 plus V1 can be expressed like this. Okay, based on these two equations, we can further derive the ADM, differential mode gain, and ACM, common mode gain. Okay, so ADM is basically the ratio between the difference of the output over the difference of the input. Okay, this over this. And if you look at this equation, when if we bring this to the denominator, what remains is just this. So this is the ADM. Okay, these expressions. Okay, these two are the same. Okay. Similarly, the ACM, common mode gain, is the ratio between the sum of the output over the sum of the input. And normally in the differential amplifier, the R2 and R3 are the same. So you can see here, if R2 and R3 are the same, this part will become 0. Okay, this whole thing will become 0. So if we take this divided by this, what remains is just 1. Okay, so a common mode gain of a differential amplifier is just 1. Next is the CMRR, the common mode rejection ratio. As we have learned from lesson 1, CMRR is simply the ratio between the differential mode gain and common mode gain. Okay, since ACM is 1, this is just equals to the ADM over here. And if we still recall in lesson 1, we learned common mode rejection ratio shows how well the signal is amplified. Okay, signal refers to the differential mode, and noise, the common mode, is attenuated. Okay, the higher the CMRR, the signal will be amplified much more and the noise will be attenuated a lot. Okay, another thing I want to highlight here is the R1. The R1 here is the external variable resistor. Usually we can connect it outside the chip and it's variable, by we can change it. So by tuning this R1, we can change the CMRR. Okay, you can see R1 is here. By changing the R1, we can tune the common mode rejection ratio of this instrumentation amplifier. Okay, thank you.